Welcome to my channel Phi Concepts CHM. This is the first part of the series of bridge course for TYBSc Electronics. In the first part, we will see about the semiconductor devices like transistor, JFET, SCR and UJT. Transistor. Transistor is a three-terminal bipolar current-controlled device. If you see the characteristic graph of the transistor, it is made up of three different regions. One is the active region, this region. Second is the saturation region, that is this. And third is the cutoff region, that is this one. Transistor as a switch. In this diagram, you can see this transistor. This is the collector resistor RC and this is the base resistor RB, and you are applying a voltage of plus VCC. Here you can apply an input voltage to the base. So now when the base input voltage is enough negative, it should be very less or it should be 0, the transistor will not work, it is cut off and no current will flow in the collector load. So hence the voltage at the collector, the output voltage we measure here, it will be ideally equal to VCC. This diagram shows the transistor as a switch. So in this case, here the switch is off. As the transistor is not working, this switch is off. And the output voltage is equal to VCC. So this is shown as the transistor is shown as an open switch. Now you apply some base voltage. So Vin is something positive about capital V. Then the transistor will saturate and then a collector current will flow, that is IC sat, will flow through the collector resistor RC, and hence under this condition the output voltage is ideally 0. So VO is 0 volt. The transistor here in this diagram is shown as a closed switch. So when the input is high, input voltage is high, the transistor is turned on as we saw, and it works in the saturation region. So maximum current IC will flow through the transistor. When the input is low, it's very low, the transistor remains in the cutoff region, so the current IC is 0. So now if you apply a square wave of this form at Vin, the input voltage is changing from 0 volt to 5 volt, then 0 volt to 5 volt, it is changing continuously. So when the input voltage is 0 volt, you will get an output voltage of high output voltage you will get, and when you apply a voltage, an input voltage of 5 volt, this is a high input, you will get a low output. So you will get at the output, you will find that it will be out of phase by 180 degree with the input. Junction field effect transistor, in short we call it as JFET. It is a unipolar device, that is, it depends on only one type of charge carrier, either electrons or holes. It is a piece of N-type semiconductor as shown in this diagram. From both the sides, from the top and the bottom, the LEDs or the terminals are taken out. The lower end terminal is called as a source terminal. Upper end is called as a drain. Two regions of P-type material are diffused into this N-type semiconductor from the two sides, and this forms the gate. This is the third terminal. The two gates are connected together in a normal JFET. So if you will see, that this forms this is N-type region, this is P-type, so this forms a diode. We can call it as a PN junction diode. So there is one diode which we call as a gate source diode, and also if you see, this is the again this P region and the N region, N-type region. This also forms a PN junction diodes. So that is, again we get another diode which we call as the gate drain diode. So in a JFET it is made up of two diodes, gate to source diode and gate to drain diode. Next is the silicon controlled rectifier. In short, we call it as SCR. It's a semiconductor device that acts as an electronic switch. It is made up of silicon because the leakage current in the off condition, the leakage current in silicon is very small as compared to germanium, which is very important when we use it as when we use any device as a switch. So the leakage current should be as small as possible in the off condition. The name SCR, silicon controlled rectifier, we call it a silicon controlled rectifier because it is made up of silicon. It is a silicon device and is used as a rectifier, and also this rectification can be controlled. Construction. It is a 4-layered PN-PN device. This diagram shows that PN-PN. So that way there are 3 PN junctions formed, J1, J2, J3. It has 3 terminals, namely this anode from the outer P-type material, cathode from the outer N-type material, gate from the middle P-type material. This is the symbol of the SCR. Next is unijunction transistor, in short UJT. It is made up of N-type bar, and into this N-type bar a P-type region is diffused, which forms the emitter. So there are 2 bases. One is called as a base 1 and this is base 2. Hence, it is referred to as a double based diode. This is the symbol of UJT with the 3 terminals as base 1, base 2 and emitter. Applications of UJT are that it is used as an oscillator and a switching trigger. This is the pin configuration of UJT. With a notch you can see the pin configuration. This is the emitter, this is base 1 and this is base 2. These are the e-resources that you can refer. This question you can attempt. Thank you for watching this video.